Another example here, and this is where I was saying earlier, the NH3, remember I said NH3 is a base, just trust me on that. It doesn't really have the OH, but watch what happens. We've got NH3, and then we've got H2O. This H on water, this top H, is going to leave, and it's going to get donated to this ammonia over here. This is going to accept it. So because this leaves, it is donated, this is called our acid. For this equation, this is our acid. And watch what we end up with. See this OH here? This, and you can look at the model here, this is OH hydroxide. So I said that it doesn't have hydroxide originally in the formula, but it makes hydroxide as a product. So it is considered a base. And like I said, this one donates, so this is our acid. Accepts, it's a base, donates acid, and then we end up with these guys, which we'll talk about in one more minute. Now, we have to look at the leftovers. There's a fancy word that we're going to learn, and it's called conjugate. What I want you to think of when you see the word conjugate is partner. This is going to be something's partner on the other side of the equation. And also I want you to think opposite. So if something's a base on one side, its partner is going to be an acid on the other side, and vice versa. So here we go. We know that acids, based on this second definition, acids are going to donate these H's. But once it loses the H, what does it become? Well, we have a fancy name for that. We're going to call it the conjugate base. And then we know that bases accept the hydrogen. And once they accept the hydrogen, well, what does it become? We have a fancy name for that, and that's called a conjugate acid. So let's take a look at these two equations here, and let's see what our regular acid and our base are, and then what are their partners. What do they look like, and what do we call them? Well, here's HCl, and here's H2O, just water. So we drop some HCl in some water, and we see that this H comes off and goes on to this structure. Now, how do I know that? I look at the HCl, and I look and say, well, what does it become? And it becomes just plain old Cl. So I know that it lost its electron because of that. So this is going to be my acid. Now its partner is over here. This is what it becomes. So we're going to add the word conjugate, and then it's going to be the opposite, conjugate base. Now over here we know that bases accept hydrogens. So that H is on its way over here. It's going to be accepted by the water, and it's going to become this hydronium ion with H3O. So this, because it accepts, is my base, and then its partner over here, we use the word conjugate, and then it's the opposite. If it's a base on this side, it's an acid on this side. So we've got acid over here, its partner is a conjugate base. We've got base, its partner is a conjugate acid. Okay, just kind of a fancy word to indicate what it becomes. And then if we reverse the reaction, watch what happens. Let me just erase the ink here so we could see. Okay, now let's reverse. We said that this was the conjugate base. This is just plain old Cl. Bases accept a hydrogen. So watch what this happens to become when we reverse the reaction. This conjugate base is going to accept the H and become this. So now it becomes HCl. And over here, we said that acids lose. This has got 3 hydrogens, and we also call this our conjugate acid. This is going to lose one of those H's, like all acids do, and it's going to become plain old water. So these do have some meaning when we reverse the reaction and we go the opposite direction. The terms that you've indicated here should hold true to our definition. Acids are going to lose, bases are going to accept. Okay. All right, real quick, let's take a look at the bottom one. We've got NH3, H2O, the same formula we saw before. This is going to turn into this because it's going to gain an electron. So this is our base, and it turns into this, which is our conjugate acid. The word conjugate because it's on the other side, acid, it's opposite. Meanwhile, H2O, it's got 2 H's, that's going to turn into this. It's going to lose, so this is our acid, and its partner over here is a conjugate base. Alright, lots more examples. Let's go through this quickly up here. Where's my cursor? Alright, we've got HCO3. So there's one H and then CO3. Let's look to see what it's bonded to over here in blue. We've got H2CO3. So we know that it accepts, it goes from one H to two H's. So that's our base, and its partner is going to be a conjugate and then opposite acid. Well, where's the H coming from? Here's H2O. It donates the H, it gets rid of one of the H's, so that's what makes it an acid. And then its partner over here is the OH. What's left after it loses an H, that's our conjugate base. Over here, H2SO4, we've got two H's. We look over here at what it becomes. So we start at that, end up with this. Now there's only one HSO4. So we go from 2 to 1, so this was our acid because it donates or loses, and it becomes a conjugate base on the opposite side. Over here, here's our water, H2O. It's going to accept that extra H, it's going to go here, and it's going to bond, and this is going to become our hydronium ion, H3O with a +1. And this last one I've shown you a zillion times already, with the ammonia reacting with the water, making NH4 and then hydroxide. Remember, ammonia doesn't have the OH in it directly, but it produces it when dissolved in water. So take a look at this real quick. Label the acid and the base. Pause this for a second, figure out which one's the acid, which one's the base, and then figure out which is the conjugate base, which one's a conjugate acid. Alright, hopefully you figured that out. This, where's my little cursor? This over here is going to donate this H, it's going to lose it, so this is an acid. Its partner is a conjugate base over here. If the HCl is the acid, the water serves as the base, it's going to accept, and it's going to become H3O. So over on this side we call it the conjugate acid. Look at these pictures now. Here's a little H, and these guys are also H's, H's, and H's. This H is no longer there when you look at what it becomes. So this is going to lose or donate, so this is our acid. It's going to become this is our conjugate base. This has two H's, and it's going to end up with 3. So this is going to end up being our base, because it's accepting one extra, and on the opposite side it's conjugate acid. Okay. Try out this picture. Pause it for a second. Give this bottom one a chance. Figure out which one's the acid, the base, and then the conjugates. Alright, so in this case, we start off with one hydrogen, but yet if you look at this picture over here, we have 2 hydrogens. So in this case, this substance is accepting an extra electron. So this one's going to be our acceptor, our base. Its partner over here is our conjugate acid. Meanwhile, this has a hydrogen, but if you look at what it becomes, it doesn't have a hydrogen anymore. So this is going to be our acid because it's going to donate, and this is our base because it's going to, or conjugate base rather, because it's on the other side. And remember, if we reverse the reaction, this base is going to accept and become that. It's going to accept the hydrogen, and this is going to donate this hydrogen, so this is going to be our acid on the way back when we reverse this reaction.